Hello, everyone. I hope you can hear me well. Thanks, everyone, for joining my session, and then thanks to the folks who are online who joined virtually as well. Well, a quick introduction about myself. I'm Sharif Mohammed, Distinguished Engineer at Capital One, focused on managing and building people data and analytics. So today I'm here to share our journey to the cloud and then how we used Spark as our core for our data ecosystem. You might have heard in many other sessions on how people are leveraging running Spark loads on Databricks. Well, in this session, I'm not going to talk about running Spark loads on Databricks, and still you can reap benefits by using open source Spark. And then you can also see, as we can see my title, you can also do this for pretty cheap. So having said that, let's get into the session. Well, what's a Spark session without a session context? So here is the agenda. Before we get into ETL tools and processing, I would like to talk about the importance of data processing, data preparation, basically. I think understanding that is important before we talk about ETL tools. And then we'll talk about our journey from on-prem to the cloud, how we leverage Spark, and then finally, I'll have 3 takeaways for you all, if that makes sense from this session. Well, let's start with the data processing. Where does it fit in the overall data ecosystem? So as you can see here, there is a popular belief that people can just take the data from the sources and then just build products. It could be AI, ML, reports, or anything. If you have worked in data for long enough, you would know that this is not true. You will end up transforming the data. The data that you need may not be the data that your source has. Maybe the join keys are different from one source to another one. You might have to join like 2, 3 other data sets just to get to a point where you can join your data. So in order to achieve that, the reality of it is like you might end up doing the transformations yourself. Now, if you don't have like an ETL ecosystem or like a kind of a sharing gold source of truth, every engineer or every scientist, they will try to transform the data themselves. And then you can imagine, like if everybody is doing the same job again and again, you are incurring costs to do the same task multiple times. Okay, and this could lead to inaccuracies, like the output from one person might be different for another person. And when they all put together, you will have the data products that you build might have less trustable outcome. So that's where the whole data processing comes in, actually. The recommendation here is that, hey, let's prepare our data first. Let's collect all of our data from our data sources. It could be from on-prem, on the cloud, or from your web analytics, or it could be from anything. Let's bring it to one place. Perform ETL. ETL stands for extract, transform, load. Now there is huge debate, and this is always on. ETL versus ELT. You might have heard this in other sessions too. I will try not getting into that. So perform ETL, process your data, build the data sets. Like before you do that, you have to kind of quality check your data, cleanse your data, identify the common data structures, basically, like flatten it up. You might have to normalize the data or like denormalize the data. This is where you might need to work with your product partners or the business partners to identify, okay, hey, this is how they would like to see the data. So that will kind of help you to kind of visualize how your target data model is going to look like in a database. So having said that, now that's what the third step is, on data warehouse. So data warehouse is a place where you host your data. Like this is all the transformed data that sits in your data warehouse. Now, once you have all of your data in your data warehouse, and right now I know, the paradigm is shifting. It could be data warehouse or it could be lake house. But the idea here is you need to have like a single source of truth. So this can work as your single source of truth, gold copy of the data. So you know that every person who is using the data is using a tested data set. You can be sure of the outcomes of the analytical products that you built on top of this data. So, but in order to get there, looking at the left part here is what we are going to focus on, the ETL part. So you have to have a good ETL ecosystem so that you can modify, transform your data as you need so that you have a good quality analytical product end of the day. All right, let's quickly talk about the evolution of ETL tools here. Now, let's look at how they were positioned like prior to cloud and then like after the cloud. So in the legacy system, the enterprise scalable tools were always like licensed. Like we had to pay like heavy license fee. And the license fee was not only for the developer, but to run the jobs in production too. The number of servers you have, the number of licenses you have to pay. The server license is different from a developer license. And as a result, like you are incurring huge cost only in the licensing fee. I'm not even talking about infrastructure costs here. So just to take as an example, like Ab initio, Informatica, Talent, and any of these tools. Now, even to hire the developers, again, like these are like niche skills. You cannot have Informatica developer work on Ab initio. Ab initio developer cannot work on Informatica. I mean, yeah, there might be a few who can get across like ETL tools, but it was hard to find people from the niche market skill. But with the advent of cloud and with companies changing the mindset more towards open source and more towards collaborative culture, the open source tools and software, it became stronger. Now it can support like enterprise scale products too. Now with the ease of learning open source languages, for example, let's take Spark as an example, okay? So anyone in college who learned like object-oriented programming, it's easy for them to pick up. So you're not fixated to one particular tool here. Instead, you can hire like multiple developers from the market, or you can train them as well. So that's one point that I want you to take from here. Like previously, you will have to kind of look into your particular tool, but now you have a wide variety of developers available for you to work on. All right. So next on, we'll talk a little bit about how we built our analytical platform on the cloud. So before we talk about our current state, I think it's good to understand like what our past was. So this was our legacy ecosystem at a high level. So the use case here is we needed an analytical platform to drive people decisions for the company. So think of it as like we have HR data warehouse, basically. So Workday is the HCM product that we use. And then we have daily extracts coming in from Workday, and then they were landing on a Unix server pretty much. The cluster of Unix servers kind of became our ETL ecosystem. And then we were using Ab initio at that time to kind of process the data, to build our data pipelines. And then we had an Oracle database, and then we had a BI reporting tool built on top of it. Now, if you can imagine, like if you have worked in these areas, you would know the challenges like working in this kind of ecosystem. We had challenges with scalability mainly. So if we have to add more jobs, we're talking like adding more servers now, more space. We had to invest a lot of time just to get that done. Now, and the same thing with the Oracle too. The data model and then the indexes, they were not that flexible for us to kind of scale easily. So having said that, we did not just lift and shift. So we redesigned our model. And when we migrated to cloud, this is how our ETL ecosystem looks like. So pretty much at a high level, you will see more of AWS here. As you all know, like Capital One was one of the early adopters of Amazon Web Services. So all the references that you see here on the slides will be AWS. But in terms of Spark, you can extrapolate the same information to Azure or Google Cloud. Now, at a high level, we have data coming from Workday, lands on S3, and then we have an EC2. I'll come back and talk about the EC2 cluster on the compute here. And then we are performing ETL on that EC2. Now, as a typical any data management solution, we were processing the data as like raw, cleanse, enrich, transform, and load. So we had a dual load system. We're maintaining both like Redshift and Snowflake. And then we have our users and enterprise applications taking the single source of truth, like well-managed data quality check data from these systems. Now, Let's focus a little bit on the EC2 here. Now, it does not have to be EC2. Once you build a Spark load, it could be EC2, or it could be EMR, or it could be ECS. So that's the beauty of the system here, actually. So it's versatile, and depending on the usage. The one recommendation that I would say is here, if you have a lot of interdependencies in a workflow, then maybe a single node cluster like EC2 might make sense. But then if you do not have much of dependencies, then you can have EMRs spinning up and processing your data. Now, an ETL system cannot stand on its own. So that's the second half of the slide that you see. So we had infrastructure management, which was kind of taking our, kind of spinning our, like automating our infrastructure pipelines. And then we had pipelines to move our code as well. So these are the tools that we use. And one thing that I want to call out is the scheduling tool. If you are using an EC2, it's a single node cluster. For workflow management, you have to have a tool. And if you let it run all the jobs on its own, it'll pretty much crash. So you have to have proper like workload management, which can manage resources on the EC2 and then schedule the jobs in a sequence that it keeps the CPU usage at an optimum limit. And then at the same time, you're getting the benefits of processing the data using Spark. Okay. Now coming to the data storage, like I said, we used Redshift and Snowflake. You also use Okera. I'll get that into Okera in the next slide. Okera was mainly to help us with fine-grained access controls over the data that we share with our enterprise. All right. So, like I said before, it was not a lift and shift completely. We saw what problems we have on-prem, and then we tried to solve them like when we migrated to cloud. There were many problems that we solved, but I'm just sharing like two key problems here. So one is data protection, improved fine-grained access controls. Now here, this is basically talks about sharing like one file with different columns to different downstreams, basically. The idea here is share only what they need. Do not share anything more. In the previous system, you might have to replicate the data in like multiple data sets. Okay, if I have to share only like 3 columns, okay, maybe let me create another file and then share that. If you keep doing that, you will end up creating like multiple copies of data. But with the help of S3 and then Okera, we have a Hive structure sitting on top of our data, which enabled us to share the data only that we require with our users. That kind of helps in many fashions, actually. So when there are regulations like GDPR, okay, like you have to share data only if you need, UK employees. So we could restrict all that. I mean, take any example like OPC Canada or any other regulatory initiative. This kind of architecture helps us to kind of restrict the data usage so that we are not oversharing our data. Now let's talk about the second one, history of histories. Now, this will probably need another session if I have to just talk about this one. Think of this as a time series data model, okay? We employed this method to kind of address retroactive transaction. Retroactive transaction is something that can change the transaction back in time, and that can have a domino effect. So having said that, if you do that, there are impacts to other records as well. Like I might come back and say that, okay, hey, this person joined not this date, but on this date. Now, which means like everybody who's reporting that person will need to change now. So we addressed all of that in this time series type of a data model. As a result, we ended up processing the data for every employee every day. So if you look at like typical SED type 2, you're just inserting or updating records. But here, we are pretty much generating the history for every employee every day. So we needed like more processing power here. All right, so the idea of sharing this point was, it was not a lift and shift, and then we had to do things differently when we migrated to cloud. And this is how Spark helped. If we were to do the same thing on-prem, maybe, I don't think like Unix or Ab initio could scale up. But with the help of Spark and AWS infrastructure, we could achieve that. So here are the benefits. We'll deep dive into each one of this. on why we selected Spark. We could have gone with like Python or any other programming language as well. But then we selected Spark for these main reasons. So the first one is like ease of coding. So there are different types of developers, in the market. Some people are comfortable with coding in native Spark. Some people are comfortable coding in like Scala or any other language. So irrespective of that, the beauty of this is ultimately, end of the day, it becomes a Spark submit command. So you can bundle all your dependencies into a jar, and then it's a Spark submit command that you have to run. And that's it, like that's how you run your workload. So, and the other option here is, let me quickly, before I go to the next slide, you might have seen in like various presentations here, like there are tools that can simplify your workloads, can do SCD type tools, and et cetera. But if you are building a complex data flow process, it becomes easy for you to manage if you have a UI. That's one thing that we lost, I would say, like migrating from on-prem to the cloud. There are many less UI-based ETL tools in the market. So having said that, we partnered with Bitwise, and then this was the tool called Hydrograph that was built, which can visually represent the data movement. Behind the scenes, it's all Spark. As a developer, when he's coding, he'll just look at the boxes. Okay, am I joining the data? Am I combining the data, or am I doing a dedupe, or am I doing a sort? So you can see all of that like visually here. Behind the scenes, this creates a Spark code. And then, like I said, same old story. It generates a Spark submit command, and then you can run that Spark submit command on EC2 or EMR or anywhere, or any of your infrastructure, basically, here. So with the one programming language, there are different ways that a developer can use, basically. It kind of gives that freedom to developers to code here. A little more about Hydrograph here. So I have provided the links on the bottom of the slide if you're interested to learn more. Think of this as just like any typical ETL product. It can connect to various sources, it can output to various sources, but what I want to focus on is this highlighted part here. So it generates a Spark-based data flow based on the UI. And you can see here, it can run on Azure, it can run on Databricks as well. So it's a pluggable architecture that can run anywhere. Again, Hydrograph is able to do that because of Spark. Spark is in the middle of all this here. Okay, so far we talked about the ease of coding here, and then different ways the developers can code. And let's quickly talk about the deployment here. A developer develops Spark code. Now he creates a jar, executable Spark code, basically. Now all you have to do is just take the fat jar, we call it fat jar with dependencies, and then combine that with the software, like Spark or Hadoop or Java. Again, you have to install this only if it's EC2. EMR comes with Spark already. You don't have to install it on EMR. Just bundle them on one instance. If you are running a single node cluster, you can use EC2. If you want to enjoy the distributed computing system offered by EMR, you can deploy it on EMR. Personally, I would recommend EMR, just because like when we started this journey, like EMR was still in the works. That's why we could not leverage EMR at the time. But EMR, it can spin up, it can run all your jobs, and it can shut down. And then it's completely auto-scalable. We'll talk a little more about EMR in the future slides here. Yeah, so this is where, if you look at the whole picture here, you have a developer who knows how to code in Spark, and then in whichever tool he uses to code, ultimately you can have the Spark submit or the jar run on any infrastructure that you like. Okay, now we'll talk about the scalability with Spark here. So as you've seen with the EMR here, one takeaway here is if anybody has worked in the legacy system, you will have to tell the process that, okay, hey, do it like eight-way partition or like four-way partition. You have to predefine that. If at all there is more data, you have to code for that to process the data in a parallel fashion. But with Spark and EMR, you don't have to do that anymore. A developer is just coding, and then EMR using the yarn modules, it can spin up like multiple tasks, and it can get the job done for you. Now, in order to prove that, I'm sharing like one of the metrics here. If you look at this, observe this graph closely. Typically, we get around 50K to 60K records, and then we process them around like 40 minutes. Okay, and there are days we get spikes around, say, close to 2 million records. Honestly, here, I mean, the graph was too spiked, so I had to like chop it off here. Even then, the execution time is constant. It's still staying between 50 to 45 minutes. So that's the beauty of combining like Spark with EMR. So like I said before, to kind of revise, the developer does not require to like write parallelism. This can automatically scale up and then process the data as required. All right, so moving on to the last benefit, actually, the cost. So overall, when we build this ecosystem and then we are continuing to build it, right now we are at like 120 input files, which comes close to 700 ETL jobs. You might wonder like how come like 120 scaled up to like 700? That's because we create like multiple layers like raw, clean, enrich, load ready, and then there is a presentation layer too sometimes. So having said that, like one file kind of transfers into like multiple jobs, and we have 700 plus ETL jobs running on one Amazon EC2 instance, which is like R5 8x large instance, and then we are paying less than $1,000 a month, which I think is pretty cheap. It's like you're paying essentially like $30 a day. So overall, to summarize, this is the gist of the story. By employing Spark-based ecosystem, you can easily hire the talent here. You're not fixated to like one single tool here, but you're having a programming language, and then you'll have a wide variety of data engineers available in the market who can code in Spark. And then you can run the workloads anywhere. You can run on EC2s or EMRs or ECS. And of course, you can always run on Databricks too. Okay, like I said in the beginning of the session, this is an option as well. And the cost of data processing is pretty low. You're looking at like just $30 a day for 700 workloads. So having said that, if you'd like to work on in a company which gives you like free hand to kind of test and learn and to experiment, going back to the pitch here, we are hiring too. And this is right from our CEO, Rich Fairbank. We recruit great people, and then we give them an opportunity to be great. So if you're interested, please reach out. You can look up kaplancareers.com, or you can reach out to me. I have my LinkedIn and then email address provided here. So any questions, I'm open right now. Yeah. Thank you.
Hi, we used to have ETL processes on EMR as well, and one thing we found difficult was actually debugging because the logs are actually really hard to access sometimes. Is this something you had an issue with? And before you moved to EMR, when you had to set up your own instances with EC2 to host the Spark UI and everything, how difficult did you find that?
Oh, you're absolutely right. So anyone who, so that's one of the reasons like why we didn't fully employ EMR was because of the logs, actually. It's difficult to read logs in EMR, but we ended up building a solution with Splunk, where we used to direct all the logs to Splunk, and then it makes it like more searchable and then easy. But then again, it's like one more hop to go to. Yeah.
All right.
All right. Then. Thanks, everyone.
Thank you.
Thanks for your time. Thank you.